My name is Baskar Subbarao. I'm with Zodiac, a small company in St. Louis that I started several years ago. And I'm really excited to be here. Thank you all for attending. This is a broad subject, and we're going to touch upon different concepts. Feel free to add to it. There's a lot of knowledge in this room. If you want us to elaborate on some things, or if you want to add to the discussion, please feel free to add to it. We're going to talk about energy performance across the building life cycle. I'm going to pass through some of the AIA slides and the copyright slides, and we'll get to the course description and the learning objectives. Learning objective number 1, we're going to look at energy performance during the design phase, which is the several different phases of doing the design, the construction, the acceptance of the building, and later move into the occupancy phase, where we go through the retro commissioning, recommissioning, M&V, MBCX, and those type of things. That's the learning objective. 2 is also looking at existing buildings. Number 3 is looking at understanding, discussion about energy, the planning, monitoring, controlling, and communicating energy. We also talk about lessons learned in the projects. Just look at the energy in general. In 2018, the EIA came up with energy consumption by end use. In the US, there's 6,787 trillion BTU of energy being consumed just by buildings. 39% of all energy consumption is in buildings, and of it 74% is electricity produced. If you look at the energy itself by end use, heating is the most significant energy use. That's about 32%, and some of the other significant ones are ventilation, lighting, cooling, and cooking. And also there are some process systems that may increase the energy consumption, but this is in general commercial buildings. If you look at the energy usage by major fuels, we have electricity, natural gas, district heating, and fuel oil. The graph on the left shows the energy distribution by end use based on fuels. If you look at this, electricity accounts for most of the cooling in a building. Natural gas accounts for the heating, water heating, cooking, and other areas. Space heating is the most prevalent of all, end use for all buildings. If you look at the energy use intensity, that is the good measure for an energy efficiency of a building. And the graph on the left shows how the EUI is reducing over the years. And the goals set are more aggressive, that they are going to go, and this, over the years we are looking to see a net zero building. On an average, in 2018, a commercial building spent about $23,900 on energy. And it can range from $5,000 for a small building to over $1.5 million for a large building. Large building could be 500,000 square feet. Hospitals consume a lot more energy. They could go 2.5, 3 million, all depends on the size of the building, but this is just some general information about, that gives us an idea about energy consumption, and that relates to cost. Now we're going to take a look at energy usage and energy intensity by climate zones. The one on the far left is the space heating, and you can see that heating is significant in cold climates. And you can see the graph that shows the cold, the distribution of heating in the cold climates. The one in the middle is cooling, which you can see the inverse of that. And then the far to right are the ventilation and water heating, which is generally independent of the climate zones itself. So now we're going to go our intent is to how to reduce energy. And what we're going to look at is just a path for high performance. And this is a graph that shows On the left is the EUI. The base building is the minimally code compliant building, which is what we call a baseline building for a new construction. Again, we are, as throughout the seminar, we've been looking at, we're not looking for a minimally code compliant building, we're looking for a lot better building. So we're going to look at strategies, how we can save energy, concepts that we can look at ways we can optimize systems and make the energy efficient buildings. So if you look at the next one, the next most significant thing is when we're looking at a design of a building is the envelope. We have lots of different strategies. It could be limited glass, better glass, high insulation, high performance windows. We can have an envelope commissioning, airtight buildings, exterior shading. There's lots and lots of strategies that we want to go back to see how can we reduce energy. Airtight building is a very significant one. And that's why doing building envelope commissioning, we want to make sure that there is a continuity in the air barrier system. Once we look at the envelope, the next is to reduce the loads inside the building. This could be use of LED lighting, reduce the loads, or could be smart outlets, occupancy sensors, and several other strategies. And these are just some basic information that we are highlighting here. Once we looked at the reduction in loads, we get into the HVAC systems, where we want to look at high efficiency systems. We want to look at strategies where we can decouple ventilation and conditioning, energy recovery systems, performance monitoring, there are many, many other strategies, but just a handful of these. So now we have looked at envelopes, reduction in loads, the HVAC system, and then there's one other significant thing is argument engagement. We look to see how we can do sub-metering, friendly competition between the users, wider set points, shared equipment, and many others. I have one, recently when I visited a hospital, I was talking to the energy manager, and throughout their facilities, their bonuses are tied to how much energy they reduce. And that's the first place, at least in my experience, where not just the energy manager, but several tiers down, their bonuses are tied to the energy usage. And what really happens is they have an incentive to reduce energy, like putting off the lights or going back and trying to make sure they can bring in outside help to get their energy down. This I thought was very impressive that they're doing that. Of course, there's one other. It doesn't work. The next one is on-site PV, which is also is a big contributor for getting a net zero building. I want to switch over to federal sustainability. I work on federal buildings, so want to talk a little bit about federal sustainability. There is EO 13514, which is Federal Planning and Programming Bureau that comes up with energy sustainability. It is mandatory on all federal buildings to have a sustainability plan, and it's mandatory on all major projects to have a federal sustainability discussion through the many different phases of the project. They do want to increase waste diversion, reduce energy, reduce water usage, and they have aggressive goals for renewable energy, reusables, and all the stuff. Now, they divide it into design phase, commissioning, energy and water projects, sustainable O&M, and education. They do talk about, modeling, smart buildings, LEED buildings, whether it's new construction, existing buildings. There are different categories of projects that they focus on trying to make sure that these goals are being met. And that goes back to the DD 1391, which determines what the goals of the projects are and eventually gets into the OPR. This is just a slide just to give you an idea about what federal buildings are doing. Now we want to go but take a look at some of the basic concepts of how we look at it. as many of you have already do know about this, that there'll be a lot of discussion about benchmarking. The first one is benchmarking, where we identify areas of potential improvement and operating savings. Now, when you benchmark, you get to know how the building is doing across many other buildings and similar buildings in the similar areas, and that helps us know how we're doing. The next phase would be is assessment, which could be site audits, commissioning, measurement verification, and others that helps us get to assess, get to know what the information we have, which then leads into data management, data analysis, and that leads to improvement and reduction. Basically, we are looking to identify, quantify, prioritize, and implement energy opportunities. Just to delve a little deeper, we get into benchmarking. This benchmarking is basically identifying areas of potential improvement and operating savings. Now, everybody's very familiar with EPA, Energy Star Portfolio Manager. What happens is that is based on the CBECS, Commercial Building Energy Consumption, and information provided from many buildings across the United States that has meter information, whether it is electric, gas, water, and those type of meters that goes into the EPA system that goes back and provides you a EUI and also provides you an energy performance index. The performance index is 0 to 100, where 100 being the best performance and 0 or 1 being the worst performance. I've seen buildings in the 80, 90 plus, but I've also seen a building with EUI of 1. So that, but that generally, but I realize that some of the the buildings that have the lowest EUIs are the ones that are really small. That's a 2,000 square feet building or a 1,000 square feet building. It's 30, 40 years old. There's not a whole lot you can do with those things. So, but then they have to put in capital. And so it just gets into capital improvement facilities more than energy efficiency measures. So that's kind of that's where some of the challenges we face there. The next one, which I've shown on the bottom middle, is the ASHRAE EQ, where ASHRAE came up with a benchmarking system where they look at the design, energy usage that was predicted, and what the occupancy is. So the one that you see 45 is the design energy consumption, predicted energy consumption. And the one that you see below, which is 50, which is what the occupied. So this gives you an idea of how it was designed, intended, and what it is being. And in this case, they have a EQ of index between 0 to 200, where 0 being the best performers and 200 being the worst performers. There are several other benchmarking. Some of them could be LEED, Green Globes. There are others, but the most prevalent is Energy Star Portfolio Manager. So now that we understand what the building is doing relative to other buildings, we get into what is called the assessment phase. Assessment phase could be an energy audit, could be looking at O&M problems, or looking at system conditions. We are looking at, if it has a BAS system, we can go collect data, we can implement a monitoring plan, we can do trend analysis, we have fault detection. We're looking to see all the data that we can collect that can then go back to look at what the customer's goals are. And there are several team members, which is the O&M, there's lots of team members that we can try to assess, help assess the building condition. And we can then discover whether the building may qualify for any incentives or recognition, and then go back to look at identifying low or no cost improvements, or maybe even going to look at potential capital improvements. So this is where in this phase is where we get into the ECMs and FIMs. Having done all of this stuff, we can now get to the next level of detail, which is getting into, if necessary, and if possible, and if you have the skills, you can go into a energy modeling that will give you either a whole building modeling or take a specific measure that you want to measure and model that particular aspects of it to see the interaction between several different factors. Or you can do a historical energy use analysis, or you can do a utility rate analysis. We've got lots of online tools that helps do the analysis, but to do all of this, you need meters, you need data, or you need to...
Sorry to derail you, but I sometimes work with federal entities that are difficult to navigate with due to IT restraints when discussing ongoing commissioning or data gathering, even if it's a one-way data push. How would you recommend we move forward?
So one of the good things about the federal buildings is all of them mandate a building automation systems. So you can get data out of it very easily, but I've seen that when you go into the EMCS department, they're more than happy to share information, and sometimes they give you more access than you need, and sometimes I'm sorry, go ahead.
So I work for Siemens, and we store data in Ireland, which is a EU-sanctioned partner with the US, but it's generally still a difficult thing for me to navigate in federal space. And even whenever I talk to IT folks sometimes and be like, hey, we're Siemens, we have the federal government group, we're here to be your partner and protect y'all, it's still really hard.
I know, because they have restrictions on what can go into their systems. So I can't get much data out of them, but if I'm inside, and so long as I stay within their system, I'm able to get data. And sometimes I ask people to email me data, or that's the only options we have. That's not, because in order for me to put any other system, it has to be certified through the IT department, and it takes forever to get that done.
We also have an email parser option that generally works with firewall restrictions, but I just didn't know if there's another.
No, I haven't found. So in fact, I'm looking at a lot of MBCX measures that does some of those things. So one other way you could do it is there are some agencies that allow you to put your own system and put a They let you do that, but it depends on what building, and what agencies. No, this is always a very difficult situation with getting data, and yes, yeah. So it goes back to data. So that's what this. It goes back to data, and the difficult part is getting the data. And once you get the data, is then the data analysis. But then talking to some of the folks, when you're working on a large building, it's easier to get a lot more data and spend the time to do the analysis. But also there are lots and lots of small buildings that don't have enough money to be able to do the retro commissioning. So we end up looking at what is their budget and doing what is called a light retro commissioning, because that's all they're looking for. Okay. It's an energy audit level 1, level 2, or level 3, those type of things. But the end goal is identifying, quantifying, and prioritizing and implementing savings opportunities. Sorry, I did go a little. So the next thing we wanted to go into is new construction. In a new construction, the two most key important things is energy modeling and commissioning. In 2019, there was a research that showed projects that used energy modeling were 32% more energy efficient. So this is the key things, and we're going to talk about new construction where in the different phases, how we can go back and be able to make sure these concepts are identified in being able to do be energy efficient into the buildings. So in the conceptual design, we look at stakeholders, the leadership team, and we want to make sure the OPR has the design, has the intended energy goals or vision put into the place. We go back and look at the local climate, the building massing, architectural design. It all goes into the modeling, which helps determine how best we can to position the building, locate the building, or to be able to look at energy efficiencies. In the next phase, we try to look at simplifying the systems, simplifying the mechanical systems. We try to combine areas, trying to shore up enough information so that forms the basis of design for the and in the basis of design has lots of narratives and details that goes back and makes sure that the systems are capable and energy efficient. In the detailed design, we look into more ways of trying to do sizing optimization and controls optimization. This is the controls optimization is very significant in being able to have the systems operate efficiently. Then we move on to construction, which is the key thing is the quality control, which goes back to submittals, making sure the right equipment is installed, it's installed properly and started up properly. We do the testing and balance. We do the functional testing. We want to make sure that the operating set schedules and set points are set up properly. We commission the control systems. We do the training, occupant education, and engagement. This then leads us to a building occupancy, which then goes into course correction and EUI benchmarking. So this is some of the key concepts in the new construction, where the end goal is having a building the owner get a building that they need that can serve the purpose and also be build efficient. Now we get into occupancy mode, and the two key aspects of the occupancy mode is to establishing an energy plan and being able to monitor it. So we're going to talk about the different phases of the occupancy phase. And in the occupancy, we continuously keep assessing the client's goals. And based on the usage of the building, we determine the approach and we keep updating the energy plan. And that leads up to, once you have a plan, you assess the energy usage. We collect information, we do energy audits, we then go back and investigate it, which involves functional testing, assessing the sequences and set points, identify energy conservation measures. So this leads to the implementation of the RECx, which then goes back to prioritization of the ECMs or the facility improvement measures, look at what capital is available, sometimes help the owner be able to go back and put in the requirements to be able to get capital for the building. Then it also goes back to occupant education and engagement, which then leads to, again, a revised or updated baseline. Sometimes it goes to a calibrated model, which becomes the baseline. And then once we have that, we then measure and verify the implementation savings that we got. Once we do this, it just goes back to an ongoing commissioning, or MBCX, where we do a proactive maintenance. We collect data, continuously collect data, and we can move on to fault detection, and we look at sustaining energy savings. And the cycle repeats itself, where depending on every couple of years or as the building usage changes. So now let's just go to, and I've talked about energy modeling. So energy modeling is key. Energy modeling is an art. It doesn't provide answers, it provides insights. And we're looking for energy savings, which is nothing but cost avoidance. So let's take a look at what energy modeling is complicated, lots of calculations, so there's lots of softwares, lots of assumptions being made, but let's just go through the overall what was being done here. We have a building form. On the far right, you'll see a building form, which determines which identifies the floor plan, the spaces, the building stock. We have the building fabric, which is the walls, floors, and the roof. And we have glazing, which is the fenestration. All of this shows up as load into the building. On the bottom left, you see internal loads. That's the people and the process loads. So we have the building loads, we have the process internal loads, and then on the far right, we have the building systems, which is what does the cooling, heating, humidification, and ventilation, which is comfort engineering. And that's based on set points, component load, equipment, and systems. On the far left, we see renewable energy. So all of this come together, which comes into an overall heat balance and air balance. That way we get the heat balance, the pressure balance, and all of those type of things. And that's what the model does, is goes back and puts together the energy consumption. Now, what we do here is we do two things. One is the minimally code compliant building, and then we go back and make changes to the model that'll help us to see how the building is being designed or operated, which then goes back and sees what the savings are. Now we talked about commissioning, so let's take a look at the commissioning itself. There are different projects, different complexities, different systems, and the different ways of interaction. So based on those, we pick the different systems for commissioning, whether it's total building commissioning or different systems as necessary. And we have new construction commissioning. And after that, as needed, you can do a retro commissioning, which could be a demand to a response to a particular situation, or can do an ongoing recommissioning, which is part of the O&M program, or could be an ongoing commissioning based on automated systems. All of this, we need meters, and in order to get data, we need to have meters that are advanced, that has a pulse, that can send to the BAS, so that we can collect data, whether it is hourly or by minute or 15 minutes, however. 15 minutes is a good way to trend, but there are requirements to be at least a minimum of 1 hour to meet the requirements. And there are several buildings, several federal buildings, and there are different codes that require at least 3 years of data that has to be put in to be able to assess the buildings. So by putting in meters, you can look at a building meter, or can go into more details as the electric, natural gas, steam, water, steam, chilled water. And by doing all of those different meters, it helps you get the end-use energy. And getting the end-use energy is key, because then you know where do you spend your time, or where is the places where you can improve, and then compare to make sure what areas are not efficient, where there's opportunities for improvement. So that comes back to the two charts that we have is electric and natural gas, which goes back to the end-use energy usage. That's the space heating, cooling, ventilation. Natural gas, which is cooking, space heating, and water heating. So now that we got the data, so now we go back to measurement and verification. Again, you cannot measure savings. So what you have to do is, savings is the absence of energy use. So you need to figure out what is it that what is it could be, and what it is, and the difference is what is the savings. So on the far left is the baseline period. So on a new construction, you don't have a building, and that's why you go into a whole building model. And the whole building model, you model a minimally compliant building, and that becomes the baseline. And and then once you design the building, you put in all the features of the design, all the improvements that you put into the design, and you can have a design phase model, and the difference between the design phase model and the energy model baseline is what is the savings. But then you can continue on to the construction phase, because what was designed may not be just as it is in the construction. So we take a look at the submittals and all the different features that is coming in, all the different occupancies, any changes in occupancy, changes in uses, or changes in system operation, which comes back to a construction phase model, which is again adjusted for weather and other parameters, and you get the post-installation period. And the energy savings is nothing but the baseline energy usage minus the post-installation energy usage. You could go one step further, and you can normalize it to a 30-year weather, and that way you're normalized the energy savings, which you can use it as your baseline. So at the end, what we're trying to do is we're looking at energy savings and facility improvements. So we're going to talk a little bit about facility improvements. And facility improvements could be based on retro-commissioning, identifying areas that you have. You can look at opportunities. It could be lighting upgrades. You can have supplemental load reductions, which could be improvements in envelope. Could be internal load reduction, could be air distribution upgrades, equipment systems upgrades, system efficiencies, or other improvements that you do. And these are generally capital improvements. And these could be, the way to identify this could be energy modeling, or could be commissioning. Energy measurement and verification helps identify what areas are not performing well, and you can look into measures and identify those. Or you could simply go to benchmarking, energy audits, and building tune-up. So these are the different ways where you identify areas of improvement. And in order to implement the facility improvements, there are several people that's involved. We've seen the other seminars that talk about all the details, and they talk about how challenging it is, and if you don't have a good system in place, you will not be able to do this right. So that's why you need to bring the whole team together, which is the owner, the commissioning agent, sometimes the architect, designer. It could be on a new construction lead AP, it could be a facility managers, controls contractors, O&M, all the folks to come on in and come up with understanding what the user wants and being able to do this. Then we go into energy conservation measures. Now, energy conservation measures is the building operational improvements or equipment installations or other upgrades that might provide energy payback regardless of initial cost. It basically reduces energy consumption and leads to savings on monthly bills. Now, in order to do energy conservation measures, you do want to define the problem and be able to analyze, and you collect data, you screen, and being able to get the owner's acceptance, and then be able to follow up in implementing these energy conservation measures. What we have done on some of our government projects, there are several ways to do this. You can have energy conservation. Some of our customers want energy conservation measures to be either energy efficiencies improvements in savings, or energy efficiency improvements, and also they want to know if it's O&M related, because they're being tracked on what are O&M improvements, and some of them is it energy efficiency improvements or energy savings improvements. So depending on the customer, you want to tweak it out to be able to provide them, because that'll help them report to their owners and their customers how they are saving energy. Some of the examples of energy conservation measures are airside economizers, demand control, energy monitoring, lighting, lockouts, resets, scheduling, and ventilation control. So when we go into a recommissioning or a commissioning, we have a whole lot of issues with the BAS that sometimes could be just sensors, actuators, could be set points, could be scheduling, could be just maintenance issues, something that's been overridden. When we go in there, we just go see a whole lot of things that have just been overridden with a note saying a customer called us, so they just go back and override it, and it's there for years and years sometimes. So those are the easy ones to get to. So, and that's why I just love it when I get access to the BAS. Just the access to, of course, sometimes I get too much access and I'm a little careful. I don't want the access, but then they'll say, here's my card. And I'm a little wary about getting somebody's card because, but then it's good that they trust me to be able to do that. But we had to be careful with that, and that's what happened. So getting to learn their system on the energy conservation measure, it's not so much as being able to do the work. It's half the thing is you just go around and talk to people, and they'll tell you a whole lot of things, and that is almost 40% of your work actually. So they'll say, this is that. And you want to have a little bit more discussion, because what will happen is you won't get to know what they're planning to do or what they've done in the past. And if you talk a little further, they'll tell you all the issues, all this. But there's also another thing. What happens is people have lots of ideas, and they have lots of good ideas. But one of the situation is, when the same thing is told by somebody internal, it doesn't get it doesn't get as much attention. Sometimes they come to me and say, you go and tell them about it, and then all of a sudden they say, oh, yeah, that's a good idea. Actually, it wasn't even my idea. So I feel bad about it, but that's sometimes the way the system works. So the people in the EMCS, the people in the O&M, the people on the data who have the document management, the designers, they are our friends actually. They have they have the same intentions as us, and you just have to talk to them, find out, and sometimes you just want to know where's this information, because there's a lot of information that we don't know where to look for, and especially when we are not there. We just have to find out where the information is, getting the information, not just the trends I'm talking about. It could be O&M. Sometimes I go in, look at the asset logs. So today in this world, there's lots and lots of data, but it's just that it's not in one place. So sometimes I would go and say, give me the asset log. It tells us the age of every building. It goes back and tells us what things have been done in the, so that's the asset log. Then we go into the O&M, there's a different system which shows all the O&M stuff. Then there's another system that goes back and says, these are the improvements that they're planning on doing. So there's all these multiple systems. You just need to go in, try to figure out what systems are available, who knows about it, where to go for this information. And that is half the problem, actually. And then all we are doing is we get all of the data, and then we do what we do best, is trying to put all these things together, do a little bit of analysis, try to make sure it makes sense. And then a lot of the times I go back to the people who suggested those things and then talk to them, and then I will get more information about emails that they've had before, that I'll get more data that'll help me figure out what the problem is, or what the issues are, and what the possible recommendations are. That's just my way of doing this. I mean, a lot of people have lots of good ideas, lots of good experience, but this has worked well for me in terms of energy conservation measures, and talking to the users has helped a lot. So in all of this, we come back to energy conservation measures. And in order, the next step is to being able to help the owner with information that they can go back and either get the money or request the money and make sure that it's a good investment. So in order to do this, we need to go back and look at we need to categorize them either by potential savings or estimated payback or client motivation. So we take a look at what is it that the client wants, what are the factors. Some of them could be lighting control, some of them could be no cost, which is 0 months to 2-year payback. There may be improvements that may be, the building envelope ones are the hardest ones. If it's not a very easy thing to do, but some of the easier ones are improving insulation. Implementing steam trap is a compressed air and steam is one of those things. If there is some of the older systems or if there's some process load, those are the kind of things that has very quick paybacks. Some of the 2 to 4 year paybacks, just examples, are balancing AHUs, installing VFDs, CO2 sensors, ventilation, monitoring, and those type of things. Some of the other ones, the more difficult ones, which needs capital, are the DDC controls, premium efficiency motors, pumps, and motor upgrades. But the key aspect from what I've known is you put all these ECMs. So what we are doing is we go back and try to go back to vendors, calculate the cost of installation, calculate we go back to even calculating the CO2 impact on the environment, and try to put in as much information that will help them identify whether it's an O&M, low cost, high cost. We go back to the vendors, get cost information, sometimes put in a schedule in there saying that we can do this in 9 to 12 months, or sometimes can be done sooner than that. We try to give them enough information that they can go back, take it to their facilities, or take it to their upper management, put it into the budget, and so that they can get to implement this. One of the challenges I have seen in retro commissioning is we put all these things together and the implementation takes a long time, or it doesn't happen, or sometimes we don't even know what they're planning to do, and our contract ends. So what really happens is we simply go back and say, okay, we try, if we are in 50 things, they may have done with 20 of those. The remaining does not happen, so we just wait for some more time. We try to do some more talking about it, and eventually it'll go away. But what we have done is when we have a repeat customer, when we go on a future project, we go back and look at the buildings that we have done, and we try to reinitiate the conversation about the buildings that we have looked at, trying to see if there's some things we can add input to that. That's how we build a relationship, especially with the customer, trying to see how we can help them and get them back on the focus in some of these things. So that's all I have for today. I'm open to any questions. This is a broad subject. We just touched upon different aspects. And if there's any questions, I'll be glad to answer.
On the slide where you were showing meters, you specifically pulse meters.
Yes.
A lot of times we don't need pulse meters. Do you have a preference for pulse meters, or there's a lot of integrated, digital meters now?
Yes. So
You were just showing an example.
I was just showing an example. What we are looking at is advanced meters.
Yes.
Yeah, so that was an older slide, and I just copied the slide. So so we're looking for advanced meters, but the problem, the metering is, I see a different problem with meters. We're putting in a lot more meters, and when I talk to facility managers, they say they don't want the meters.
Right.
So I go back for retro commissioning, and I say, oh, that's great, the meters is there. But it hasn't been calibrated, some don't communicate. We don't have the data. And when I do the trending, a lot of data is missing. Then I go back and ask them, can you recalibrate? They don't have the budget to recalibrate. So I see a lot of meters being put in. And if you really, when you talk to some facility managers, they don't want those meters actually. So there's a fine balance between what it is, so what we are doing is we go back and look at what is it that they want to measure, what is it that they want, or what do they want to verify. Without meters, without data, you cannot, if you don't measure, you cannot verify. So you need that, but the thing is, just because you have a lot of meters doesn't mean you can verify it. There's a fine line between adding meters and what you can verify. So you need to have the meters in the right location, doing the right end users, so that's when you can do that. Otherwise, you have to go back to your own. So I have had situations where people will come back to me, I don't want these meters. But that's the facilities talking about it. So there's a fine line. I don't know if that's my experience actually. And anybody else had any experience about meters, people talking about it? Yes?
So data quality is a really big component of a building automation system because like meters are cool to install now if you have the ability to afford that, but there's plenty of sensors in place that are inaccurate, that may be hidden in a duct somewhere, and you can want to do fault detection from that system, right? And so, sorry, but I think everyone should be thinking about the data quality that is a component of the screening process when you're doing ongoing commissioning or monitoring-based commissioning, because there's just a lot of information you're going to get out of a building, and that should be a part of your thought process.
That's a good point. We were doing, if you all remember, LEAD 3.0 had 3 points for measurement verification. We had a lot of projects that we had measurement verification, and we had committed to doing the measurement verification. So we go in, so it requires that you do meter for anything over 10% usage to be metered. So we were asking for those meters and all those stuff. And we go back a year later. Yes, getting the data was the first thing. So we would go back and keep asking for the data, and sometimes I would go to the site just to get the data. So that was and then once I get the data, I open up, a lot of the data is missing. I mean, for months there's no communication. So now what happens is I have to go back and look at how do I make up for the missing data. So you can look at analysis to say, okay, you don't have the data, but you still have to do the analysis. So you either have a choice to either make up for the data, that is, do some interpolations and all those type, and then make up for the data, or you have to say this data is no good, which means if the data is no good, there's no analysis to be done. So what happened on the measurement verification is, there's another problem with that. We did the measurement verification, and nobody wanted the data. Nobody wanted to see that because the engineer did not want to know how the building was operating. Because if we did say, if it came out that we wasn't doing well, they don't want to know. And if we told the owner it was not doing well, then they have a problem. Do they go back to the engineer and say, why did they design it? So it's created a whole lot of things. So we were very careful how we write that report, because it got into a legal, there was one situation where we were sub to a architect engineer, and we told them this is not doing well, but we are sub to them. So we went back, and so he said, no, they basically told us that we did not do the right analysis, we don't have the right data, so we tried to do some improvements, and that was that. So there are some situations that comes in with this. It's never an easy thing with this, but if you get a lot of good data, at least you can go back and look at how, we can at least look at where the buildings are not functioning well and do the ECMs. that's kind of where any other ideas, anybody else, any suggestions on metering, measurement, verification?
I just got a question based on the energy modeling. Just your experience, if you've had better experience using engineers' models that they create during the design process or doing your own energy modeling, and if it's the second option, kind of what programs you use and what you recommend for doing that.
Okay. In an energy model, it's very hard to use somebody else's model. It's just their thinking and the way the data they put in and all the stuff. So we always tend to want to create our own models. And also, we have had situations where our customer asks for a specific program. So everybody standardizes on a program, but because we're a smaller company, we tend to be open to this. So we wanted to use Energy Plus on one of the projects, but the customer came back and said, you have to use eQuest. So we build on our systems and build on that. So I was looking at different, all of these programs have strengths. The train trace is good with systems, engineering systems. They do a very good job with that. eQuest is simple, but the DOE, the background check calculations are easy and it's good. But the eQuest does not have, it's simple, but doesn't have heat recovery chillers, chill beams, and all those type of things. So what we are ending up doing is we're taking the model, putting information, and sometimes we have to take data out of it, create another supplemental, for example, heat recovery chiller. We just go back, take it to our own models, do the analysis, and try to put that in and then model it. That's kind of what we're doing on the eQuest. Looking at long term, I see Energy Plus. I've seen a long-term vision where a lot of data can come from different ways into Energy Plus. I mean, every other systems is different. They're all changing. It depends on the customer. I had one customer who wanted to standardize on eQuest, so we went back to eQuest. So we are primarily doing more eQuest because of requests from the customer. But that doesn't mean that's the best. All I'm trying to say is it's easy and the customers like it, so we are using that. And we try to learn the system and put more of a background analysis to make it work for us. In fact, we're taking the data from eQuest, taking out of there and creating our own reports, our own charts, and all of those. That's what we do because we are using eQuest. I don't know if that answered it. Calibrating the models. Energy modeling calibration. So as I told you, so we have hourly modeling. So you do the base modeling and you do so we have a project with the healthcare. We've got into in the design phase. So we are going to be doing the design phase modeling as it was designed during the phase of the design, and we'll have a model at the end of the design. We'll also have a model at the end of construction, and then they want us to have a model at the end of 1 year occupancy. So we're going to take all of the construction documents and see if there's some of the energy efficient, put those in to update the model. And we hope what to do is take the 30-year energy data and calibrate it to the 30-year data. That's what we're planning to do, is having a design phase model. We'll have a baseline model, which is the minimum code compliant. We'll have a design phase model, then we move on to a construction phase model, and then we move on to a calibrated model. And the difference being occupancy, change in occupancy, change in set points, change in operations, and that's kind of what we are doing. So we have a healthcare project that we are targeting 171 EUI. but there's a lot of assumptions. And in healthcare, there's too many assumptions that goes in, and we are glad to be part of the project. We hope to get enough details so that we can calibrate the model based on, that's what we are planning to do. Yeah.
Thanks for the presentation. I guess on one of your slides you had like savings by use type, right? And I was surprised, or not really, I guess, the more I think about it, but just how, you know, like healthcare was the one that had the least savings potential, right? Even though it's probably the most energy intensive building use type that's up there, right? So I guess I'm just kind of curious, you're commenting on, you know, how EUI or energy intensity doesn't necessarily mean it has the most energy or most savings potential. So I just, yeah, I was kind of curious to comment on that.
Healthcare EUIs is like 215. Well, that's because we have ORs, which is 100% outside air. So some of them are 100% outside air. Office is 50 EUIs, so they're all very different. So that's why we go back to payback periods, simple paybacks. We just look at the energy savings. We look at the EUI for the buildings to identify what buildings to look at. But then once we get in there, we start looking at what is the energy savings, what is the cost for energy savings, what is the simple payback, and we prioritize them. We talk with the users and say, here's your payback, here's your cost. We just have one thing called low cost, no cost, and FIMs. And then we start talking about, here's your payback, and we want to make sure that they do all the no cost. We want to do all the no cost, and we go back to the low cost, and then the low cost. The other ones, we have not much control. We just tell them the savings and then try to give them vendor costs, and then leave it to them to prioritize. I don't know if that answers your question. So with healthcare, it's very difficult to get changes done because there's too many players. If I want to do something with the air handling unit, we had something where we want to do something. They said, no, we can't direct it until the doctor is there because there's the infection control and also pressurization control. We all of a sudden, it said, no, you can't do this because unless the doctor is there, the nurse is there, the facility is there, and all this stuff. So eventually, the doctor is the one who's letting us know if we can do it or not, or when to do it. And they said, I can't give it to you for more than 3 hours down. So the air handling unit can be down only for 3 hours because he or she is saying, that particular floor, I don't want anything to happen to that patient. So with hospitals, it gets very complicated. And I was so surprised that we were not talking technical stuff, we were talking patient care. And that's the number one. Hospitals, patient care is the number one. So it wasn't a question about energy savings, it wasn't a question about this, it wasn't even a question about when. It was the doctor trying to say, do you want to do it? When do you want to do it? And then they came back to say, why do you want to do it? Tell me why you want to do it because it's my patient kind of thing. So anyway, I kind of digressed here, but thank you very much. I appreciate I am very happy to be here and thank you for doing that.